Now, first of all, this is section A. So this is section A, and it is forces and motion. Forces and motion. Now we can call this thing as mechanics. This whole thing can be called mechanics. Now you know what mechanics means, right? Mechanics means it is the study of force and its effect on motion. So that is what mechanics is all about. Now the first thing that we're going to talk about is movement and position. So let's talk about movement and position. Movement and position. Now, movement and position can be thought of as the description of motion. How do you describe motion? Meaning, what is description? If you see something, how do you describe it, right? If you see something, so that thing is called the description of motion. So when we see something, so how can we describe motion? We can describe motion using a number of terms, and these terms are speed, then we have distance. Well, speed is the distance traveled in time. So anything traveled with time, so distance traveled in time, so that is speed. So by definitions, for speed you know distance, and you need the definition of time as well to describe something. And of course we have acceleration. Give me a moment. So acceleration gives you change of velocity with time. Now I have used a new word called velocity, right? So what is velocity? Velocity is actually speed, a simplified version of speed. What does that mean? It means if I am talking about speed, I'm talking about it can move in any direction. Velocity means speed in a specific direction. So it has speed in a specific direction. That means we cannot just talk about speed here, not only speed, but we have to talk about direction as well. So you might say velocity is a simpler version of speed, because speed can move this way, that way, anyway. Now, so we have another simpler version called displacement. Displacement is a simpler version of distance, meaning it is distance in a specific direction. So here we have both distance and direction, meaning it has to be the distance in a specific direction. So if it goes in a straight line, we have to consider that to be the positive displacement, and if it goes in the opposite direction, we'll consider it to be the negative displacement. So we have to consider that to be as a displacement. So it's like a simpler version of distance. Time, it has no such thing. And acceleration, by default, remember, acceleration in physics is change in velocity with time. It is change in velocity with time. It is not change of speed with time. So it means if something is moving with constant velocity, but if it is moving in a circle, is the acceleration changing? Yes, because if it is speed is same, but if the direction is changing, then you will say that the velocity is changing, because speed is not the only definition of velocity, but speed in a specific direction. So if something is moving with a constant speed, but the direction is changing, we will say because of the direction the velocity is changing, and since the velocity is changing, we will say that the acceleration is changing. Is that clear? So you have to remember, even if something moves in a constant velocity, it's still a constant speed, it still might have a different acceleration if it is changing direction constantly. So remember that, this is very, very important. So these are the tools with which we describe the motion. Now one thing is important is the unit. Now when we talk about unit, we have to make sure you understand that there is such a thing called base unit. So the base unit for distance is meter, the base unit for time is second, the base unit, these two are the base unit. Now from the base unit we can find derived unit. So the derived unit for speed, of course we're going to refer to it velocity, but speed is fine, is meter per second, and the derived unit for acceleration is meter per second squared. So that means, so when we have base unit, these two are the base unit, so from the base unit, from this and from this to base unit, we can actually get derived unit, right? So the unit is extremely important. So now the basic formula is, if someone says what is the definition of speed, of course we're going to refer to it as velocity. So it is going to be, velocity is going to be displacement by time, right? Now velocity can be broken down into two parts. One symbol is u, it means initial velocity, meaning at the beginning, and another one is v, is called the final velocity. So acceleration is change of velocity, meaning final velocity minus initial velocity divided by t. Okay, so that is going to give you the acceleration, and you know the unit of acceleration. Now the next thing that needs to be talked about, it's the concept of the pictures, the graph, the speed time graph. Now for the speed time graph, you have to know some basic concept. Now when we talk about the graphs, there are two types of graphs, the speed time or the velocity time graph. It should be referred to as velocity time graph, right? So when we talk about speed time graph, the first thing, let's talk about constant acceleration, meaning the velocity is changing constantly. So the x-axis is going to be t and the y-axis is going to be v, and it's going to be a straight line. So this is O, origin, this is called starting from rest. This is moving with a constant velocity, constant acceleration. So this, when you see this line, it means it's moving with constant acceleration. So this is the first one to memorize. Now on the other hand, if it is moving with constant deceleration or retardation, then the picture is going to be like this, right? So it is going to fall down, the velocity is going to decrease with time. So that is constant deceleration. Look here, the line is going down, meaning as the time is increasing, the velocity is changing. Remember, change can mean both increase, that is also a type of change, and also decrease. They are both types of change. Now of course the common sense is, if it is constant velocity means the acceleration is zero, it is not accelerating at all. That means the velocity is not going to change, it is going to be the same. It will be a horizontal line. That's how it's going to work. Now one thing that is important is the concept of the gradient of the line. Now what does that mean? The gradient of the line is this. If something has like this, it is accelerating. If you're talking about this line, we know it is accelerating. But if we take another line that is a bit above it, we will say this has a higher acceleration. Now then if we take another line something like this, we will say that it has a higher acceleration, meaning because it is more above that. So the acceleration is actually the gradient, because the gradient of a graph is change of y-axis, meaning the rise, and the forward change of x-axis. So if you do this side divided by this side, you'll find the gradient. So here the gradient is of this picture is the acceleration. So the gradient is the acceleration, because the gradient is velocity, change of velocity by time. So that's how it works. Now one more thing that needs to be talked about is the distance traveled can be found. Distance traveled can be found by finding the area under the graph, under the speed time graph. So when you find the area under the speed time graph, you can actually find the distance traveled. So if we do an example, suppose you have the journey of a car. So at first, it starts from rest. Starting from rest means starting from here. So it accelerates up to a point. So suppose it moves for 10 seconds and it accelerates to a velocity of 10 meter per second. And then it moves with constant velocity, horizontal line, for another 20 seconds. So this will be 30 here. And then it decelerates to rest in the next 10 seconds. So this would be 40 here. So this thing, if you want to find the distance that this car travels, all you need is the area of this triangle, area of this rectangle, and area of this final triangle. So if you add it up, that will be equal to the distance traveled by this car. So that is the main idea. Now the next thing that we need to talk about is displacement time graph. Displacement time graph is going to be a bit different, not that different. The logic is going to be same, but it's going to be a bit different. So distance time graph. Now distance time graph, it's different in the sense that since we are now talking about distance and time, the idea would be a bit different. Suppose if it's about constant acceleration, it would look, since we have distance and time, so the constant acceleration, the symbol for distance is usually x. So the constant acceleration might look something like this. It might look something like this. Now constant deceleration is also the same. So if it's deceleration, it might look like this. It is decelerating. So this is constant deceleration. Now when we talk about constant velocity is going to be a straight line like this. It's going to be a straight line because you're moving constantly. It doesn't matter whether you're moving with constant velocity, it will still be moving because you're covering distance. Even if you're moving with constant velocity, as time is passing, you are covering distance. So this is constant velocity. So whenever we are talking about constant velocity, it will not be a horizontal line. Horizontal line means it is not moving at all. So when you have something that is not moving, so space is very low, so at rest or not moving, only then you will have a horizontal line like this in the displacement time graph. Right? So whenever something is not moving at rest, it's going to be a horizontal line, meaning time is going but this thing is not moving at all. So this is how it is going to work. And one more thing that should be mentioned, that in displacement time graph, whenever we're talking about this distance time graph or displacement time graph, usually what happens, there are two pictures. Suppose this is a distance time graph, so you can consider this as city A and consider this as city B. So in a distance time graph, what usually happens, suppose one person goes from town A to town B, so with constant velocity, then at rest, then with constant velocity. So usually there is no acceleration here in this type of sum. They don't bother with this type of acceleration or deceleration, just moving from one town to another town. Now in speed time graph, moving up means it is accelerating. Remember, this is a displacement time graph, so this is not accelerating, it's moving with constant velocity, and this was at rest. Now at the same time, suppose there's another person coming from the other city, from city B or town B, and he's coming with constant velocity, no stopping or anything, so constant velocity, and they reach here. So this is the point where they overtake each other, or where they meet. So they meet at that point. So remember, displacement time graph is like coming from one place to another place, so from here to here. So this line, it looks like deceleration in speed time graph coming down, but here this line does not mean deceleration, it's coming from one city to another city. So that's the idea behind that. So whenever you do displacement time graph, you have to remember it's a bit different from speed time graph, and you should not mix the two.